with the 7.1D. Following the last test, here are these 3 questions. Okay, so let's start with the first one, class 9 maths. Okay, chapter 7, B3. Find this on page 130, all these questions. Let me read the question. Okay, the diagram is given, so let's draw that first. Something like this is given here. So draw along with me here, perpendicular sign, and here 90-degree sign. O, C, dash, then B, and here A and D here. Okay, and this BC is indicated to be equal to AD by the single dashes here. Okay, so let's start here. Given to us, as simple as look into your question and write down what is given in the question. So AD and BC are equal. So important to note this, they are equal in length. Perpendiculars. Okay, let us write this one in short like this. Perpendiculars to a line segment, in short you can write SEG, segment AB. So we have to prove. Show means to prove only. CD bisects AB. So let us try to reassess this into a simpler form. CD is this line. CD bisects AB means the word bisect means CD will divide AB into 2 equal parts. That means prove that AO equal to BO in simpler meaning. So if you can prove this, that means CD bisects AB, in other words. Let's start the proof, means the answer for this. So in triangles AOD, let us go like that for this. So we started from perpendicular point A, then went to O. So for the next triangle, this one also we have to go in the same way, because in similar and congruent triangles, putting the letters in the right corresponding position is absolutely important. So A we started, which is 90 degrees, so we have to start the 90-degree point for the next triangle. So B. When to O means the corresponding is O itself. This has to be written last, therefore. So in these 2 triangles, AOD and BOC, we have to write here angle 1, and this one is angle 2. Angle 1 here and 2 here. So they are clearly equal because we can see they are each being 90 degrees, because they are mentioned as perpendicular here, means 90 degree. And if we were to indicate this by angle 2 and this by angle 3, then angle 2 inside this triangle AOD is equal to angle 3 inside triangle BOC, as you can see here. We know because this is because they are vertically opposite angles. These 2 are straight lines cutting each other, so up and down here, vertically opposite. So we so far managed to prove that 2 angles of this triangle are equal to 2 angles. You can just get one side to be equal, then that will be fine. So here AD, which are the first and the third letter, is it equal to the first and third letter? Let us check. BC here, first and third. And here given AD and BC are equal, you see. So that means, in other words, AD equal to BC. So that is given. So we have managed to prove that 2 angles and one side here, 2 angles and one side inside this are equal to the 2 angles and one side in the second triangle. So we learned this in the previous class, that in such a case, the 2 triangles concerned here, triangle BOC and AOB, will be congruent by using a condition, congruency condition we learned in previous class, by using double AS, angle side, congruency condition of triangles. So now if 2 triangles are congruent, we know that two things always follow. One is corresponding sides are equal, corresponding angles are equal. We need a side. So AO are the first, second letters. Corresponding means the same position, first and second letter. They are equal for sure now, because CP, CT, congruent parts of congruent triangles are always equal, even the sides and the angles. But we don't need the angles here. Let's go to the next one, B4. Go about it slowly. I hope you're getting it right. Okay, so let's go grade slowly at a pace that is comfortable to you, so you can pick it up without much difficulty. Go there. Question 4. L and M are parallel lines. So see, the figure is given, so let's just draw that first. Two lines here parallel given. Another one here. Okay, let's make it a little bit longer then. Another one here. And then clearly mentioned as this line is L parallel to M, and this line P parallel to Q. This line is mentioned as Q. These points are mentioned as A point, B, C and D, and the diagram is given as SC joint. So let's write a given. Given is L and M are two parallel lines, intersected simply means cut, intersected by another pair of parallel lines P and Q. In other words, first here L is parallel to M line and P is parallel to Q. That's what the question means. So with this we have to prove that triangle ABC is congruent to triangle CDA. Let's try to do that. Proof means the answer for this. We have here L parallel to M, because that's given to us, as we can see here. So if this line L is parallel to M, that in other words means this segment AD, which is part of L, and segment BC, which is part of the M, will be parallel to each other. Right? You're getting right. Okay, so next here, similarly, we can just write here, okay, like this. Similarly, P parallel to Q means AB parallel to DC. AB parallel to DC. In other words, that is ABCD is a parallelogram. We have found out, because we know a theorem which says if in any quadrilateral, means four-sided figure, means quadrilateral, opposite pairs of sides are parallel, then it is nothing but a parallelogram. This theorem we're using. AB parallel to DC, AD parallel to BC means opposite sides are parallel in the four-sided figure ABCD. So this is a parallelogram. So if it's a parallelogram, then this angle here 1, these two here ABCD are far away, means opposite angles. Okay, 1 will be equal to angle 2, because we know that opposite angles of a parallelogram are always equal in degree measurement to each other, right? Okay, so let us just keep this one as equation 1, because we're going to need this later on. Then let us see here, this one, P parallel to Q. P parallel to Q, let us take again, since it is given. As you can see here, P parallel to Q. So if this line is parallel to this line, you consider SC as transversal, then this angle here, 3 and 4 here, inside down, inside up, that is nothing but we learned in our previous lines and angles chapter, that is alternate angle. And if the lines are parallel, surely the alternate angles are equal. So this is equation number 2. I think now we're ready, so we can just take those two triangles we're trying to prove are congruent triangles. ABC, CDA, ABC and CDA. Most probably the question is arranged correctly, that's why we're just taking it like that. Then here, in this triangle, angle 1 inside ABC, as you can see, is equal to angle 2 inside this CDA. As you can see, CDA. Because this one by using equation number 1. Okay. And next here, angle 3 inside ABC. Yes, ABC equal to angle 4 inside angle C, triangle CDA. Because we get this one by using equation number 2. Now you see here, this side here, SC, first and the third letter, equal to first and third letter CA or not? SC and CA are same, right? SC, CA, because this is the common side of both triangles. It belongs to both triangle, in other words. Therefore, we can write your final answer. If you like, you can write it here in a space that is more. So therefore, triangle ABC will be congruent to triangle CDA by a condition called using AAS, two angles and one side, congruency condition of triangles. So this is one way by which we can prove this one. Okay. Next, the last question, 5. B5. We'll just go about it slowly so we get it properly. Okay, so here B5 on the same page 130. Let's draw the diagram directly. It's because it's given there. See here a line like this and a line going this way and another line going this way, and then we see here a line dropping, making 90 degree BP, and here A. We see here another line going down perpendicular here, 90. This is Q, and we may see this one mentioned as plane L also, and this much is given. So given to us here, just write down as it is, line L, this line L is the bisector of angle A, meaning this QAP. Divide this into 1 and 2, then these two are equal, in other words. Okay, so, and B is any point on, means not outside but on, situated on the line L. In other words, 1 equal to angle 2. L is bisecting angle A, means angle 1 equal to angle 2. Bisect means divide equal into 2 equal angles. So with that we have to prove two things. So I'll just write down to prove. 1, triangle APB congruent to triangle AQB. Second thing you have to prove here, BP is equal to BQ, or in other words, B is equidistant from the arms of angle A. Just try the proof. You just start here. Proof means your answer. So let's start with the first one directly. In triangles APB and AQB, which we are trying to prove are congruent, these two triangles. Here let us start here. Put here 3 and here 4, these perpendicular ones. Go 3 inside APB and 4 inside AQB. They are equal because we can see clearly they are 90 degrees each. 90 degrees each. Okay, then let's go to the next one. 1 inside angle APB. APB, this one, equal to 2 inside AQB. QB, because it is given in the question itself that L bisects angle A, as you can see here. If you can pick one side, they are equal. AB, let us say first and third letter, and corresponding side means in the other also first and third. Exactly, they are the same actually. First and third, AB. They are equal because their common means belong to both triangle. As we can see, AB belongs to this triangle APB. AB also belongs to triangle AQB. So we know now that if two triangles are such that two angles and one side are equal to two angles and one side of the other triangle, those two triangles will be congruent by a condition called AAS, angle side congruency condition. We have learned this theorem in one of our previous classes, right? So the first one is proved. So this is your first answer, as you can see here. Now to prove this, BP are the third and the second letter. So I take that. Same third and second I have to take, that only it's corresponding. They are equal because they are corresponding parts of congruent triangles. The second answer, right? So this is how you go about 3, 4, 5. I hope you got it right. Okay. So now you can go and give the test.